Hello, this is Mr. Win, and this video is about simplifying radicals. So a radical is simply a term that uses the square root sign. For example, we see square root of 64. There are lots of ways to pronounce or say it. I put my favorite or the most common one in red, but you can also call it radical 64 or even root 64. Another example is 3 root 10. Again, that's the most common way of saying it. I put in red, but you're allowed to call that 3 square root 10, 3 times square root of 10, and even 3 radical 10. A side note, when you square root a number, you actually get two answers. One answer is the positive form of a number, while the other answer is the negative form of that same number. For example, the square root of 64 is both negative 8 and positive 8. Negative 8 times itself, a negative times positive, so positive 64. Also, positive 8 times itself, positive 8 times positive is still positive 64. Alright, so for geometry, sides and angles can't be negative, so we don't even care about the positive version usually. We don't really mind or care about the negative version. And like fractions, a radical must be simplified. To simplify a radical, use the prime factorization method or tree branch method to break down the numbers into the smallest factors. Then you find or circle the pairs when you're doing square roots. And anything successfully paired goes on the outside of the radical sign, while anything unpaired goes on the inside of the radical sign. If there are multiple numbers on the outside, they do multiply together, and if there are multiple numbers on the inside, they do multiply together. So for example, we have square root of 96. So if I break it down, 96, that is 2 times 48. And then this is gone, like I broke it down. 2 is prime, so I leave it alone. 48, that is 2 times 24. That's gone. 2 is prime, 24 is not. That is 2 times 12. And then 12, that is 2 times 6. And 6, that's 2 times 3. Alright, now I chose the breakdown by 2, divide by 2, divide by 2, divide by 2. If it's even, you can always do that. But if you pick bigger numbers, it's actually faster. So now I'm going to find pairs. Here is a pair of 2s. Here's also a pair of 2s. And the last 2 has no pair, the last 3 has no pair. It has to be matching. So pairs go on the outside, one of each. So from the first pair, a single 2 goes out, the other 2 disappears. If you want to cross it out, you can. For the next pair of 2s, a single 2 goes out, the other one disappears. And those that unpaired 2 and 3 stay inside the radical, the root sign. 2 stays inside, 3 stays inside. Like I said before, you multiply. 2 times 2 is 4, that's on the outside. Inside, 2 times 3 is 6. That is the answer. The square root of 96 is the same thing as 4 root 6. So we just found out that the square root of 96 is the same as 4 root 6. Let's see what the calculator says. If you type in the calculator, you'll see this. Square root of 96 is this 9.797 decimal. 4 root 6 is the exact same 9.797958 blah blah decimal. So again, notice that the same decimal value, and that's what we should expect because they're equivalent. They're just, one is just the reduced version or form of the other. Now I put decimal in quotations because it's actually impossible to write this entire thing. It goes on forever without any pattern. It can't even be turned into a fraction. Numbers like this are called irrational numbers. So if you still have a radical in your answer after simplifying it, it is an irrational answer. Alright, you are expected to simplify these by hand. The calculator will not be able to get the final answer for you, but it can help you divide big numbers when doing the tree branch method or prime factorization method. And also remember that unless otherwise stated, we always want the exact answer. You should not be using decimals or rounding at all. If I say, what is the square root of 96? You need to tell me 4 root 6. This is true. Alright, if you tell me square root of 96 is equal to 9.8, that is wrong. Again, it's not 9.8, it's not 9.7, it's not 9.79. It goes on forever. You cannot list the number. So we want exact solutions. Now the only exception to this is when the directions literally say to round, and on Get Over Math they will do that. So in that case, if they tell you to round, there's no point in breaking it down, simplifying it. Just type in calculator, use that decimal. But on all my tests, I'm going to expect the exact answer, no rounding. Alright, here's another example. The square root of 64. Alright, so some students already know the answer is 8. But whether you know that or not, you're always allowed to simplify it using the tree branch method. You'll still get the same answer. So let's say I don't know it's 8. I'll say, well, what does 64 break down to? It could be 2 and 32, but let's see different. Let's say, oh, it's 4 and 16. That's allowed. Alright, 4 breaks down to 2 and 2. 16 breaks down to 4 and 4. 4 breaks down to 2 and 2. This other 4 breaks down 2 and 2. I broke it down to all primes. I'm going to circle the pairs. Here's a pair, here's a pair, here's a pair. Look, everything got paired up. So for the first pair, a 2 goes out, though the 2 disappears. The second pair, a 2 goes out. Third pair, a 2 goes out. There's nothing left inside the square root. If there's nothing inside the square root, it disappears. 2 times 2 is 4, times another 2 makes 8. Make sure you don't multiply two things at once. That is the answer. That's why the square root of 64 is 8. So if you have a big number, you know what the square root is, just break it down tree branch. That always works. All right, so we just found that the square root of 64 is the same thing as 8. That's pretty obvious. I typed in the calculator. Square root of 64 gives 8. 8 equals 8. Notice they're the same value. Again, that's what we should expect because they are equivalent. One is just the reduced version of the other. Now this time, we did not get an infinite non-repeating decimal. The answer could be turned into a fraction. 8 can turn into 8 over 1. That counts as a fraction. Numbers like that are called rational numbers. And if the radical disappears in your answer after simplifying, it is a rational answer. Now, instead of doing the full simplifying process, which again you can always do, there are times when you're allowed to show no work. This is when the answer or simplification is obvious. If you have a perfect square, no work is needed. A perfect square is a number that is square rootable with no radical sign left over after simplifying. You should know or memorize the first 15 perfect squares. 1 squared equals 1. So 1 is a perfect square. You can square root 1. Square root of 1 is 1. 4 is a perfect square because you can square root 4. Square root of 4 is 2 because 2 squared is 4. 9 is a perfect square. Square root of 9 is 3. 3 squared. 16 is a perfect square. Square root of 16 is 4. 25 is a perfect square. 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. If you see one of those numbers, you can just square root it. You don't have to do the whole tree branch method. Now you can. Again, 64 is on there. So if you know the square root of 64, you can say 8 right away. No work needed to show. But if you don't, you can do this full tree branch method. But again, save yourself some time. Learn those perfect squares. All right, other facts about simplifying radicals. If two radicals are being multiplied and they're the same type, for example, they're both square roots, which in geometry that's going to be the case, you are allowed to combine them to a single radical and just multiply the inside numbers. Just be sure to simplify afterwards if possible. So here's this, what is the square root of 2 times the square root of 6? They're both square roots, so I can make them a single square root, just multiply the insides of 2 times 6. Well, 2 times 6 we know is 12. And then I have to break down a square root of 12. So I'll do it right here, it's really small. You can just say 12 turns into 4 times 3, then 4 turns into 2 times 2. Here's a pair, so 2 goes out, a 3 stays in. That's why the final answer is 2 square root 3. All right. The bottom, same thing. There could be numbers in front. Front numbers multiply front numbers. Inside numbers multiply inside numbers, just like when we reduced the first thing, the square root of 96. So negative 4 root 3 times 8 root 5. Well, negative 4 times 8 is negative 32. 3 times 5 is 15. I check, can I simplify that further? 15 doesn't break down into any pairs. It's just 3 and 5, no pairs, they multiply back together. All right, so that's it there. We also have division. If two radicals are being divided of the same type, again, they're both square roots, which should be the case in geometry, you are allowed to combine to a single radical, single square root, and just divide the inside numbers. But again, be sure to simplify afterwards if possible. This says, what is the square root of 8 divided by the square root of 2? Because they're both square roots, I can say, oh, let's just make it a single square root of the single fraction 8 over 2. Well, you know 8 divided 2 is 4. And then the square root of 4, that is a perfect square. We know the answer is 2. All right. Last slide. If your final answer is a fraction, it may never have a radical in the denominator. If you do, you need to rationalize the denominator by multiplying the top and bottom by the denominator, and then use the multiplication rule we just went over 2 slides ago. And again, be sure to simplify afterwards if possible. So here's the exact same problem from the last slide, square root of 8 over square root of 2, but I'm going to use the rationalize the denominator method. So we know the answer should be 2. Let's see. I can't have a square root on bottom, so I'm going to multiply both the top and bottom by root 2 over root 2. And that's allowed because it's multiplied by formula 1. Remember, when you multiply square roots, they can make a single square root, just multiply inside, so 8 times 2 is 16. On the bottom, square root of 2 times square root of 2 is square root of 4. But look, the square root of 4 is just 2. On top, the square root of 16 is just 4. Then I reduce 4 divided 2 is 2. Same answer. All right, also, a trick you should know, when the square root multiplies itself, it's just the inside number. So, for example, square root of 100 times square root of 100 is just going to be 100. Square root of 3 times square root of 3 is just going to be 3. All right, down here, last one. It looks kind of weird. 10 over 3 root 5. I can't have a root sign on the bottom, so I multiply by... You can multiply the number, I just multiply by the root 5 root 5. So that's all we need to get rid of. On top, 10 times root 5 is 10 root 5. On bottom, that's going to be 3 root 5 root 5. But root 5 times root 5 is root 25, which is just 5. So again, when you have a square root times itself, root 5 times root 5 is just the inside number 5. So that's going to be 3 times 5. I'll do it like that. So on bottom, I can simplify that. 3 times 5 is 15. Then I can reduce. So radicals can only reduce other radicals. So I don't do anything to root 5, it's done. But 10 over 15 outside numbers, they can interact with other outside numbers. So 10 divided by 15, I can divide top of 1 by 5 to get a 2 over 3. So this will be 2 root 5 over 3. And there is one easy way. You can always check your answer. If I type 2 root 5 over 3, again, there's no rational or radical in the denominator. It's going to be the exact same thing as 10 over 3 root 5. That's it for the video. Hope you enjoyed it. Make sure you ask any questions during the live sessions. Ask. Thanks for watching. Bye.